So in this video, we're going to go over the Mach 10 review. First question. A scientist collects a bacteria sample that begins with 7 million microbes. The sample doubles in number of microbes every 30 minutes. The sample can be represented by the exponential equation y is equal to 7 times 2 to the t over 30. Which of the following represents the equation to solve for t? So all we're going to do here is move things. Okay, so the first thing we would do is divide y by 7. So that's going to now give us y over 7 equals 2 to the t over 30 power. Now we're going to write it as a log. So the base is the base, so log base 2 of y over 7. That's equal to t over 30. And we would multiply both sides by 30 to get our answer. And that, if I'm not mistaken, is A. Alright, the next one says Billy solved an exponential equation and found a solution of -4. Which of the following equations could Billy have solved? So let's go ahead and just put -4 in here for x, okay? So this is 5 times 2 to the -4 is 2 to the 4th is 16, so this would be 1 over 16. So that is equal to 5 over 16 because you multiply across top and across the bottom. So that's our answer right there. So the next one says a times 10 to the bt equals c, where a, b, and c are positive. Then which of the following expressions is equal to t? So once again, we're going to solve for t. So this one is a times 10 to the b times t equals c. So we would divide both sides by a. So we get 10 to the bt power equals c over a. Now we're going to write it as a log. So it would be log base 10 of c over a equals bt. So now we're going to divide everything by b. Now recall that if it's log base 10, then it could just be written as log, right? So this one is, let's see, c over a, b, so that's c right there. Okay, the next one says the world's population can be projected by the following exponential growth model. N equals n to the 0 e to the kt power. So n equals the future value and 0 present value. K is the rate of increase. T is the number of years over which the growth is to be measured. So this first one says at the start of 2022, the world's population is around 7.95 billion. The current growth rate is 1.08. What is the world's population expected to be in 2029? So I'm going to subtract 2022 from 2029. So that means my years are going to be 7. So when I solve for A, which I'm going to do right here, we're going to write the equation n equals 7.95 to the e, and we're going to put this, move it 2 places to the left, so that's going to be 0.0108, and then we're going to multiply that times 7. We can go ahead and just put that in our calculator, and when we do, we get 8.57 billion. That's what we expect our population to be in 7 years. So then it says, in what year would you expect the world's population to exceed 9 billion? So this time, for part B, we're going to put 9 here, and we're going to put our 7.95 there. We're still going to put our e here and our 0.0108, and this time we're going to solve for t. So we can divide both sides by 7.95. And when we do that, what did I get? I got 0.1241, and that's equal to 0.0108. E to the 0.000108 t. Okay, so we're going to ln both sides. We're going to do the ln of the 0.1241, and we're going to do ln of the e. So when we do that, sorry. No, that was supposed to be 1.13, guys. Sorry. Yeah. This is supposed to be 1.13. And then, okay, then when we do the ln of 1.13, that's going to be our 0.141, and that's going to be equal to the 0.0108 t, divide both sides by 0.0108. So t is going to be equal to 11.49. Now it asks us, in what year would you expect the world's population to exceed 9 billion? So if we add 12 to the 2022, so we do 2022 plus 12, that would be equal to 2034. So with number 5, we're going to go ahead and work this. So we're going to get the ln by itself. So we're going to subtract 6 from both sides. So when we do that, we get 2 ln of negative 3 minus 6 equals 2. We're going to divide both sides by 2. That's going to give us ln of negative 3x minus 6 is equal to 1. Now we're going to take e of both sides to get rid of the ln. So that's going to give us negative 3x minus 6 equals the ln e to the first is going to be that 2.7183. Then we're going to add 6 to both sides. So when we do that, we get negative 3x equals 8.7183. And then we're going to divide both sides by negative 3. So x is equal to negative 2.9. That's what I got. All right, so the next one has, we're going to divide both sides by 12 first. So when we do that, we're going to get e to the 3x plus 2 equals 5. This time we're going to ln both sides. We're going to ln this side and we're going to ln this side. That cancels that out, so we get 3x plus 2 equals the ln of 5. And when I took the ln of 5, I got 3x plus 2 equals 1.609. Then we're going to subtract 2 from both sides. So when I do that, I get 3x equals negative 0.3906. Divide both sides by 3 here. So x is equal to negative 0.13. Whoops, where'd that go? Let me go back, y'all. Right there, C. Okay. All right, so our next one's number 7. And on number 7, we are going to change this into an exponential. So we're going to say 5, our base to the power of what's on the other side, is equal to 3x plus 9. So that's 25 is equal to 3x plus 9. Subtract 9 from both sides. So that's going to be 16 equals 3x. Now we're just going to divide both sides by 3. So x is going to be equal to 16 over 3. And that was A. So the next one says evaluate without using the change of base formula. So this time, notice we have the same bases here, so we just get 31 there. Now we are going to have to figure out what our base is over here. Log base 8 of 8 to the what power is 4096. So I just did trial and error here, and I took it to the 4th. So when I did that, those cancel out, right? So I'm left with 31 minus 4, which is 27. So number 9, ln of 9x plus 1, or 9x plus 7 equals negative 1. So the directions for 9 through 13 were find the inverse. So what we're going to do is go ahead and swap our x and y. So I'm going to put an x here, and I'm going to put a y there. So that's going to be my first step. X equals ln of 9y plus 7. Minus 1, add 1 to both sides. So that's x plus 1 equals ln of 9y plus 7. Now, we got to take e of both sides to get rid of the ln. So this is going to be e to the x plus 1. So this is e to the x plus 1 equals 9y plus 7. So we're going to subtract 7 from both sides. So this is going to be e to the x plus 1 minus 7. And that's going to be equal to 9y. So then we're going to just divide both sides by 9. So that's our answer right there. So that one is C. All right, the next one, again, we're going to swap our x and y. So when we do that, we're going to subtract 6 from both sides. So this is going to be x minus 6 equals 9 to the e times e to the y minus 1. So now we're going to divide both sides by 9. So x minus 6 divided by 9 is equal to e to the y minus 1. And we're going to ln both sides. So that's going to get rid of that. And then we're just going to have equal to the y minus 1 over there. So we're going to have to add 1 to both sides. So this is going to be ln of x minus 6 over 9 plus 1. That's going to be equal to our y. So that's number 10. I'm just making sure that I did it right. All right, so let's go on to the next one, number 11. So here again, we're doing x and y. So we're going to add the 1 to both sides. So it's going to give us x plus 1 is equal to the log base 5 of y plus 7. Write it in exponential form, so it's going to be 5 to the x plus 1 power equals y plus 7. So we're going to subtract 7 from both sides. So it's going to be y is equal to 5 times x plus 1, to the x plus 1 power. Didn't make that very high, did I? To the x plus 1 power minus 7. So that was A. All right, so our next one, we're going to again swap our y and our x. So actually, let's make this x. X and y. So we're going to say log base 3 of our x equals y minus 2. Yep. So now we're just going to add 2 to both sides to get our answer. So we're going to say log base 3 of x plus 2. That's what equals y here. Okay. So our next one, again, swap x and y. So this is x and this is y. So we're going to subtract 1 from both sides. So we got x minus 1 equals 5 to the y power, right? So we're going to say log base 5 of x minus 1. That's what equals y. So this one is B. 14 says, how long does it take for an investment of $1,200 to double at an annual rate of 7.25% interest, compounded continuously? So this is our key phrase right here, compounded continuously. So we're going to we don't have to really use this number. We could just say 2p equals p to the e 0.0725 t. Both sides we can divide both sides by p, so we're going to be left with 2 equals e to the 0.0725 t. Recall again, we're going to use ln to cancel out that e. So that's canceled out, and so we take the ln of 2, which is 0.6931, and we set that equal to 0.0725 t, and we divide both sides by 0.0725. So our answer is t is equal to 9.6 years. So on number 15, this one says Thomas invests $5,500 in an account that pays 7.25 interest per year. After how many years will his investment be worth $11,000? So we're going to put $11,000 here, and that's going to be equal to our initial amount was $5,500. We're going to do 1 plus our 0.0728. Recalling that we're going to move that decimal place 2 places to the left. So now we're going to divide by 5,500 here, and that's going to give us 2, and that's going to be equal to our 1 plus. So it's 1.0728 to the t power. So now we're going to write it as a log. So we're going to say log base 1.0728 of 2. That's what's going to be equal to our t. So now we can do this with a change of base formula. So we're going to do the log of 2 divided by the log of 1.0728. And when we do that, we get 9.9 years. That's how long it's going to take for the money to basically double. Okay? So the next one says, write each expression as a single logarithm, then simplify if possible. So the first thing I want to do here is move these coefficients to be the exponents. That's going to be my first step. And then I'll see if I can simplify after I do that, okay? So we're going to put our log base 9 one time. And then this is going to be y to the 6th on top because it's positive. And then we've got x to the 3rd on the bottom because it's negative. Then we've got 2 to the 4th is 16. And then we've got minus, that goes on the top because it's positive. And then 2 to the 3rd is 8. So these two right here are going to reduce. So I don't know why I put an equal sign there, y'all. So this is going to be log base 9 of 2y to the 6th over x to the 3rd. The next one says expand. So this time I'm going to actually apply this first, and I'm going to rewrite this. And I'm going to put that 3 to every power that was there. So I got log base 6 of x to the 3 times 5 is 15. This is going to be y to the 3rd, z to the 3rd, okay? So now I'm going to write it. Log base 6, log base 6, log base 6. So this would be x to the 15th, which means the 15 is ultimately going to move there. This is going to be minus y to the 3rd. So again, this is going to move there. And then z to the 3rd. So again, this is going to move here. So let's write our final answer. I'll write it right here. So this is going to be 15 log base 6 of x minus 3 log base 6 of y minus 3 log base 6 of z. And 17b says the same thing, expand. So what we want to do with this one is see if we can reduce first. And I do see a z on top and a z on the bottom. So let's go ahead and rewrite this first. So let's just say log of. So that 4 is going to be reduced by 1. So that's going to end up being 3 up there. So this is going to be x to the 5th, z to the 3rd over 5, y. So this time we're going to end up with 4 terms. So this is going to be log of x to the 5th plus log of z to the 3rd minus log of 5 minus log of y. Keeping in mind again that these are moving up here to be the coefficients, right? So this is going to be log 5 log base x. I'm sorry, log 5 log base x plus 3 log base z minus log of 5 minus log of y. Keep in mind, guys, that the 5y is still going to break up because everything up here is being multiplied, okay? So you want to keep in mind that everything is being multiplied. If there's being multiplied, you're going to end up with 4 terms up there, okay? All right, so this next one says simplify. So what we're going to do first is we're going to do our x's and our y's. So our x, 15 over 3, and I'm going to go ahead and put this x, 6 over 2 below it. And then we got our y of 8 over 4. And our y of 18 over 3. So that's going to give me 15 divided by 3. That's x to the 5th over x to the 3rd. This is y to the 2nd and y to the 6th. So what do we do with those things in the denominator? Don't we subtract them? So we're going to subtract 3 here and we're going to subtract 6 there. So this is going to be x to the 2nd, y to the negative 4, which is going to make it x to the 2nd over y to the 4th. So our answer there is going to be C. Number 19, let's see if I can get some room down here to work. So I'll go back up here. So once again, I'm going to put the like terms over each other. So I have my x to the negative 6 over 3 and my s to the 9 over 3. And then I'm going to do my t to the 5 over 4 and t to the negative 3 over 4. Okay. So what I want to do is see if I can reduce these first. So this is going to be s to the negative 2 over s to the 3. And we're going to ultimately subtract that, right? So that's going to be s to the negative 5, which means it's going to go to the denominator. In this one here, we're going to go t to the 5 over 4 minus a minus 3/4. So that's going to be t to the 8. Remember, this is going to change into plus right here. So it's going to be 8 over 4, which means it's going to be t to the second. So it's going to end up being t to the second over s to the fifth. T to the second over s to the fifth. So where's that one? So that was our d. So for 20a, we're going to go ahead and multiply both sides here by the square root of 4x plus 13. So we can get rid of that in the denominator. So that's going to give us x plus 2 equals the square root of 4x plus 13. Then we're going to square both sides. You can use the box to square the x plus 2 if you need to. That's going to give you x squared plus 4x plus 4, and that's equal to 4x plus 13. So we're going to subtract 4x from both sides and the 13. So that's going to give us x squared minus 9 equals 0. So the factors of that are going to be x plus 3 and x minus 3. We're going to set both of those equal to 0. So this would be x equals negative 3, and this would be x equals 3. Now recall that you got to check these, right? So if we put the negative 3 in there, negative 3 plus 2 is negative 1. And negative 3 times 4 is negative 12, plus 3 is... So this would be negative 1 over 1, which would not be positive 1, it would be negative 1. So that means we know for sure that this one's not working, okay? Now we do the 3, that's 5. And if we do 3 times 4, that's 12. 12 plus 13 is 25. The square root of 25 is 5. And if we do a 5 over 5, that's 1. So this is our answer right here, the 3. The negative 3 does not work, and it's deemed an extraneous solution, okay? So in this next one, we're going to subtract 4 first from both sides. So we're going to get x minus 4 equals the square root of 6 minus x. I'm going to square both sides to get rid of that square root. So this is x squared minus 8x plus 16 equals 6 minus x. So we're going to add x to both sides. And we're going to subtract 6. So this is going to give us x squared minus 7x plus 10 is equal to 0. So our factors here are going to be x minus 2. Because we're looking for the factors of 10 that add up to be negative 7. So x minus 2 and x minus 5. So that means our two terms are going to be x equals 2 and x equals 7. Let's see if these work. So let's do 2 up there. So if 2 is equal to 4 plus 6 minus 2, so that would be 4 plus the square root. Well, that definitely can't be true, is it? So it's definitely not the 2. Because if we did the 2 here, 2 there, and 2 there, we would get the square root of 4, which is 2, and 4 plus 2 is 6. So that's definitely not 1. Let's try the 7. So now, let's go in here and do the 7. So if we do the 7, well, we can't take the square root of a negative number, can we? So, where are we at for 20b? Oh, where'd I get 7 from, y'all? That would be the problem. It's supposed to be 5. X equals 5, so let's put the 5 here and the 5 here. So that's going to be 1, square root of 1, 4 plus 1. Yep, that one does work. Okay, there we go. All right, so this find the inverse. So again, we're going to put x here. We're going to put y there. So our first step will be x minus 5 equals minus 5/6 y. So we got to multiply by the reciprocal of negative 5/6, and we got to make it the y positive. So we're going to do negative 6/5 here, and we're going to multiply negative 6/5 by everything over here. So that's going to give us negative 6/5 x. And when we multiply a negative times a negative, we get a positive. So that's going to be 30 divided by 5, which is plus 6. And that's what y is going to be equal to there. So this is negative 6/5 plus 6. So that would be d right here. Our next one also says to find the inverse of. So again, we're going to put x there and y there. So our first step would be to add 6 to both sides. So this is x plus 6 equals the 4th root of 7y plus 2. So we're going to have to take it to the power of 4 to get rid of that 4th root. And so now we get x plus 6 to the 4th equals 7y plus 2. So we're going to subtract 2 from both sides. So it gives us x plus 6 to the 4th minus 2 equals 7y. So our last step would be to divide by 7. So that is our inverse right there. X plus 6 to the 4th power minus 2 all over 7. 23 says, which of the equations has a range of negative infinity to 3? So let's look at these in decimals. So we're going to go in here, square root, negative square root of negative x plus 4, and then minus 3. So this is asking us for a range. Well, the range here starts at negative 3, so we know that's not the case because our range starts at 3. And it does go to negative infinity, but it's not the right sign. So let's look at B. So we have to just remove that negative out front, right? And we have to make this a plus. So this one now, if we look at B, it is going to positive infinity, isn't it? Yeah, so this is from 3 to positive infinity. Okay, so now let's look at C, which would just not have this negative out front of it, right? I don't know where I got a 4 from, y'all. Let me go ahead and fix that. We're going to change our signs, but just for our x value. Minus 1. Let's go ahead and do a minus. And then plus 3. So again, this one's going from 3 to positive infinity. So here's our last one. Put the negative out front. There's our answer. So it was D because it starts at negative infinity and goes up to 3 there. There it is. Okay. So our next one is a graph. It says if f of x is equal to log base 3 of negative x plus 4 plus 2, which statement's true. So we can see our graph here. Remember, we're going to build this wall right here. And this wall is at x equals 4. Okay, so that means my x values cannot go to the right of that. So my domain is going to be from negative infinity to 4, right? And my range is going to be all real numbers because there's no limits to what happens with my y values, right? So, and then remember, our interval of, this would be an interval of decrease because this graph is going down. So we're going to write decrease here. And then as I head towards the 4, we're going to negative infinity. And as I head to negative infinity, we're headed to infinity here. So as x heads to the left, that's definitely not true because this is headed towards infinity. We just talked about that, right? The infinity's up here. So that's not true. And then domain is from negative infinity to 4. That looks like it's our true statement, but let's keep going. We said this was a decrease. Everything else there is correct. And then as we head right, we're really heading towards 4 here. So this is not true. This is not true. So that's our answer right there is B. Okay. So this next one, which statement is false? So again, we want to look where our graph starts. It starts at, what is that? 1, comma 4. And as we head left, isn't the graph headed down? So it is. So that's a true statement. Domain is going to be from negative infinity to 1, isn't it? It is. So that's true. Is this graph increasing on our domain? So this would be our answer, right? Right here, because this is the false statement. So this should be going to what? Our 1, right? So that's our false statement. And then our range is going to be what? From negative infinity up to 4, isn't it? So, and that's also correct. So here's our answer right there. Here's our last one. So this was which statement describes the graph. So this is an exponential graph. So we have a horizontal asymptote at x equals y equals negative 2. Okay. So let's talk about our domain again. This looks like it's all real numbers. So it's from negative infinity to infinity, right? What about our range though? Our range is limited, right? So our range is going to go from negative 2 up to infinity, isn't it? So once again, is this graph increasing or decreasing? It's increasing and on the interval of our domain, right? Be great if I could spell today. So which statement describes the graph? That means we're looking for a true statement. So as I head left, I'm going this direction. Where's the graph headed to? Isn't it headed to -2 here? So this should be -2. So that's definitely not true. Our domain is from -infinity to infinity. So that should be an infinity right there. The interval of decrease, well, wait a minute, this is increasing, isn't it? And that is from -infinity to infinity. So this one was also wrong. So our last statement is our range. And what did we have for our range? -2 to infinity, right? So we're looking for a true statement again here. So that was true.